Properly constructing a fabric is not unlike building a building or some other complex structure. The components of the fabric and how they're assembled relate to its physical properties, aesthetics, and costs. The manufacturer controls these inputs to meet the customer's needs, as well as to make a consistent product in a cost-effective way and to meet production expectations. The customer needs to understand how the product is made to ensure they're getting what they ordered and at a fair price. Fabrics are made on various systems, primarily knit and woven. The type of yarns, the sizes, the thread counts, and other variables of the fabric can be measured at production and at retail. The key attributes that can allow for proper analysis of product are fabric weight, fabric count, width, yarn count, and others. Fabric count is also known as fabric density. It's a measurement of the amount of yarn used in the fabric for a specified area, normally 1 square inch. In woven fabrics, the warp and filling threads per square inch are referred to as the thread count. Further, if the size of the yarn is known, then a fabric density or fabric cover factor can be calculated. For this CD, it's not necessary to calculate the fabric cover factor. However, it's clear that with the same thread count, the larger the yarns used in the fabric, the denser and the greater the cover. Also, if the size of the yarns isn't changed, then the greater the thread count, the denser the fabric and the heavier. More information on cover factor can be found in The Art of Weaving CD, published by Cotton Incorporated. The thread count of a woven fabric is the number of warp ends and the number of filling ends per inch. The warp count is always listed first. The fabric count of 100 by 45 would be 100 warp ends and 45 filling ends per square inch. ASTM test method D3775, warp end count and filling pick count of woven fabric, gives clear instructions on how to measure these numbers. Depending on the width of the woven sample analyzed, the density of the yarns, or the complexity of the pattern, more than 1 inch may be counted in each machine direction. In addition to the thread count, the size of the corresponding yarns is often listed. In the example above, the 100 by 45 may be followed by 26 by 18, which would indicate 100 warp ends per inch of a yarn number of 26 singles, and 45 filling ends per inch of a yarn size of 18 singles. Other information could indicate fiber content and other pertinent yarn data discussed in the yarn section of the construction chapter. Fabric density for knit fabrics is referred to as stitch count. Knitted fabric loops are formed in rows and columns. The horizontal rows of loops are referred to as courses, and the vertical columns of loops are referred to as wales. Knitters most often list the number of courses first and wales second. In this illustration, there are 5 courses per inch and 5 wales per inch. Therefore, the stitch count would be 5 by 5. A typical apparel single knit sweater fabric would have a stitch count of 18 by 12, which would be 18 courses by 12 wales. The reason knitters list courses first is because it's a direct measure of the production for that machine for a given fabric and relates to the cost of production. However, most test reports refer to the wales first and the courses second. Therefore, a stitch count for them would be 12 by 18, referring to 12 wales by 18 courses. The reason the wales are listed first is that the number of wales per inch is similar to warp ends in woven fabrics, and the number of courses are similar to the number of filling ends in woven fabrics. The accurate measure of width for a fabric for cut and sew processes is very important. The efficient allocation of markers for cutting is based in part on the usable width of the fabric. The measurement of width must take into account the type of fabric, whether woven or knit, and the type of selvage. ASTM test method D3774, width of textile fabric, gives 2 methods of determining the width of a fabric. Generally, the usable width of a woven fabric is over the selvage, but inside the fringe of the fabric. In this example, the measured width is 50.25 inches. Open width knitted fabric is normally measured between pin marks from finishing or inside the gum if gummed and trimmed as a precaution to curling during cut and sew. Shown first is measuring inside the pin marks. The width of this fabric is measured at 47.5 inches. Shown here is the measurement of the knitted fabric inside the gummed edges. Care must be taken not to stretch the fabric when measuring the width, especially knits. The width of this fabric inside the gum is 67.25 inches. Tubular knitted fabric width is measured to the outside edge of the flat tube. This fabric's tubular width is 36.125 inches, which means that the total width of the fabric, if opened, would be 72.25 inches. The term weight of a fabric relates to the mass of a specified area of fabric. Mass per square yard or meter and mass per linear yard or meter are the most common expressions of weight. Some people will use the term yield when referring to weight. ASTM test method D3776, D3776M, Standard Test Methods for Mass per Unit Area, Weight, of Fabric, covers the measurement of fabric mass per unit area, weight, and is applicable to most fabrics. Within the test method, there are 4 approved options. Option A uses a full piece, roll, bolt, or cut of fabric to determine the weight. In this method, the length of the available piece of fabric is determined, normally from shipping documents. The width is also measured. The entire piece or roll of fabric is then weighed. If a roll or bolt is weighed, the roll shell or holder is also weighed. If the shell or holder can be removed, it should be weighed by itself. The net weight is determined by subtracting the shell weight from the total weight. The weight per unit area can then be calculated within the following formula. If a weight per square area, such as ounces per square yard, is to be determined, a factor of the total area of the sample and the specified area should be determined. This factor is used with the total weight of the roll to determine the ounces per square yard. For example, if this roll of fabric has dimensions of 1.67 yards width by 80 yards length, then the area would be 133.6 square yards. Therefore, if the net weight is 50 pounds, then the total weight is divided by the total square yards to give weight in pounds per square yard. This would be equal to 50 divided by 133.6 to give 0.374 pounds per square yard. Multiplying this number by 16 ounces per pound would yield a weight of 5.99 ounces per square yard. If the metric system is used to express the weight per square area, then the values would be grams per square meter. For example, if the roll was measured at 73 meters long by 1.52 meters wide, then the total area would be 111.0 square meters. If the weight is 22.7 kilograms, then that number divided by the square meters would result in a value of 0.205 kilograms per square meter, or 205 grams per square meter. Another option, B, makes use of a full-width specimen. This procedure is applicable to a full-width sample cut from a full piece, roll, bolt, or cut. Unless otherwise specified, these results will include salvages and will be on the basis of conditioned fabric. Option B is not recommended for the acceptance testing of commercial shipments, since Option A is regularly used for that purpose. From each roll or piece in the lot sample, cut, don't tear, at least one laboratory sample the full width of the fabric, and at least 250 millimeters, 10 inches, in length. The cut edges must be a straight line, free of indentations or bulges, and parallel to each other. Measure the length and width of the conditioned specimen by a suitable measuring device. Weigh the specimen in grams, ounces, or pounds on a scale or balance to the nearest 0.1% of its mass. Calculate the mass per unit area, mass per linear yard, or linear yards per pound to 3 significant figures, unless otherwise specified. The total area is determined. For example, if the piece of fabric is 60 inches wide and is 12 inches long, the width and length dimensions are converted to yards, which would be 1.67 yards by 0.33 yards. Therefore, the square area is 1.67 yards multiplied by 0.33 yards to yield 0.55 square yards. If the specimen weighs 3.3 ounces, then the ounces per square yard would be 3.3 ounces divided by 0.55 square yards to give a calculated yield of 6.0 ounces per square yard. The formula is as follows: area weight equals sample weight over square area. Textile and apparel manufacturers often communicate fabric weight in terms of weight per unit length and length per unit weight. Ounces per linear yard and grams per meter are common expressions of weight per linear length. These expressions have importance, especially for cut and sew operations. In the above example, where the piece of fabric is 1.67 by 0.33 yards, the entire width of the sample is used. The length must be adjusted to a 1-yard length. Since the length is only 0.33 yards, this must be factored to equal a yard. Therefore, the weight of the specimen, 3.3 ounces, is divided by the measured length in yards to give the ounces per square yard value. This would be 3.3 ounces divided by 0.33 yards of length, and would equal 10.0 ounces per yard. A description of yield of linear yards per pound is important when fabric is sold by the pound. The more yards per pound, the greater the number of garments that can be made from the fabric. If the yield of ounces per yard is known, then this is converted to pounds per yard by multiplying by 16 ounces per pound. This would be 10.0 ounces per yard divided by 16, and would equal 0.625 pounds per yard. Once this is known, yards per pound is the reciprocal of pounds per yard. The formula is yards over pounds equals 1 over pounds per yard. Therefore, in this example, the yards per pound would be 1 divided by 0.625, which equals 1.6 yards per pound. Option C allows for determination of weight using a small swatch of fabric. This procedure is applicable when the available amount of fabric is limited. A small swatch of fabric is sent to the laboratory to be used as a test specimen. The results are considered to be applicable to the sample only, and not necessarily to the lot from which the sample was taken. Measurements by this method do not include fabric selvages. Option C should not be used for acceptance sampling due to the small size. The most common manner to sample these small specimens is with a cutting die to cut specimens from different locations in the sample. Either square or round dies are available for this method. Some die cutters are designed to allow for a direct reading of weight using a scale that weighs in grams. The size of the die circle is designed for this purpose. In these systems, 1 to 8 circles are stamped to give a direct reading. The number of grams will be equal to the ounces per square yard. These systems can give good results if conditioning and sampling criteria are followed. Option C also allows for weight testing when only small amounts of fabric are available and die cutting is not an option. In this option, a small specimen of known length and width is cut and weighed. Then convert the length and width of the specimen to a square yard. For example, a 6 by 6 inch square can be cut and weighed. In a square yard, there are 1,296 square inches. The 6 by 6 sample has 36 square inches. Therefore, there are 36 samples in a square yard. From this, the small sample's weight can be multiplied by 36 and converted to the proper yield. If the weight of the small sample weighs 4.729 grams, this can be multiplied by 36, which gives 170.2 grams in a square yard. Since there are 28.375 grams in an ounce, the ounces per square yard would be 170.2 divided by 28.375, which equals 6.0 ounces per square yard. If a 20 by 20 centimeter square is cut, then there are 25 squares of this size in a square meter. If the specimen weighs 8.144 grams, then the grams per square meter is 8.144 times 25, which equals 203.6 grams per square meter. Option D is intended for use with narrow fabrics as designated by the trade. These fabrics are usually 300 millimeters, 12 inches in width or less, have a selvage on both sides, and are woven on multi-shuttle looms. The weighing system for these fabrics is not covered in this CD. However, the detailed ASTM test method thoroughly covers this method.